In this example, May has a budget of $100 and she can spend it in two places. She can go to her local pub Zanzibar, which cost her $20 per night that she attends there. And she can get dinner at a Chinese restaurant, which costs her $10 per dinner. Okay, so if we see how far that $100 budget goes, if she were to spend all of it at Zanzibar, $20 per time, she could go 5 nights. If instead she were to spend her entire $100 budget at the Chinese restaurant, which is $10 per night, then she could go have up to 10 dinners there. Right, so we can draw this as a budget constraint, which is an application of our production possibility frontier. So on the x-axis, I'm going to put Chinese restaurant meals, and on the y-axis, I'll put nights at Zanzibar. All right, so at most, she can go to Zanzibar 5 times, and the Chinese restaurant 10 times. Okay, so the slope here is -1/2. Okay, so, and the slope also tells us the opportunity cost of eating at the Chinese restaurant. Each time she goes to the Chinese restaurant, she gives up half a night at Zanzibar in terms of how much it would cost. So our first question is, if May decides to go to the Chinese restaurant 6 times and Zanzibar 2 times, is that within her budget constraint? Can she afford that? Right, so 6 times at the Chinese restaurant and 2 times at Zanzibar. Does that fall within this budget constraint? So there are 2 ways to determine this. One is to simply add up what the cost would be of this combination. So 6 times $10 at the Chinese restaurant plus 2 times spending $20 at Zanzibar. And that would be 60 plus 40, which is in fact $100. So if we draw that on the production possibility frontier or the budget constraint, we see that we would be right on that budget constraint, not within it and not beyond it either. Okay. Another way to answer this question would be to actually move on to part B of the question, which asks us to write a mathematical equation describing May's budget constraint. So to do this, we can say, what is the most number of times she can go to Zanzibar? 5. And then every time she goes to the Chinese restaurant, she gives up, hence the negative sign, half a trip to Zanzibar. Okay, so that's her mathematical equation describing the production possibility frontier we drew here on the left side. So then to go back and answer the question in a different way, can she afford 6 nights at the Chinese restaurant and 2 nights at Zanzibar? We can simply plug in for either C or Z in this equation and see what the equation spits out in terms of the maximum possible number remaining. So here, let's say we plug in for Chinese restaurant trips. So can she go there 6 times and still have enough money left over to go to Zanzibar twice? So 5 minus 3 would be exactly 2 trips to Zanzibar are possible, and that's what she's choosing. So yes, this is all possible. Part C of our question gives us a new scenario. It says, so assume that May comes into some money and can now spend $200 per month. So her budget has just doubled to $200. Okay, so that's going to double how many times she can go out to eat because the prices of the meals or the visits haven't changed. So she can now go 10 times to Zanzibar or 20 times to the Chinese restaurant or some combination within. If we draw that on her graph here, we're simply going to double our numbers from 5 to 10, from 10 to 20. Okay, and our slope doesn't change because the trade-off between Zanzibar and Chinese food has not changed. It's still a 2-to-1 ratio, so the slope is still -1/2. Okay, now part D of the question asks, with her new budget, let's say she decides to go to Zanzibar 8 times and the Chinese restaurant 4 times. And the question is, not only are they asking, is this possible, okay, but is it efficient? Okay, efficient, when we're thinking about production possibility frontiers, means we're right on the line. We're not sort of underspending our resources, which would be inefficient. All right, if we're being inefficient, it means we can get, let's say, more Zanzibar trips without giving up any Chinese nights, and vice versa. We can get more Chinese nights without giving up any at Zanzibar. That would be an inefficient allocation of her budget. If she's being efficient, the only way to get more Zanzibar visits is to actually give up some Chinese nights, and vice versa. So let's determine whether this new allocation, 8 and 4, is possible and is it efficient. Okay, so again, there's 2 ways to figure this out. One is to calculate how much is she actually spending. So if she goes to Zanzibar 8 times, each trip costs 20. And if she goes to the Chinese restaurant 4 times, and each of those trips cost $10, then she is spending $160 at Zanzibar, 40 at the Chinese restaurant. So she is exactly spending her budget. We can draw this up in the graph, the new graph that we made. So if she goes to the Chinese 4 times, she can still just exactly go to Zanzibar 8 times, and she will exactly spend her $200 budget, no less and no more. Hey, the other way to answer this question is the allocation of 8 and 4 efficient is to actually tweak the equation we created for the budget constraint to reflect the now higher budget, and then to plug in either the 4 or the 8 and see what the equation for the budget constraint tells us is actually possible. So how will this equation change when May's budget goes from $100 to $200? Well, we already determined that the slope does not change. The trade-off between Zanzibar and Chinese nights is not different now that she has a higher budget. But what's possible in terms of absolute visits to either is now different. So the new equation is going to be, rather than starting with a y-intercept of 5, which was representing this number, now she can go to Zanzibar up to 10 times. So that number goes from 5 to 10. Again, the trade-off or the opportunity cost of Chinese nights is not different, so the slope remains at -1/2. All right, so now we can plug in 4 for Chinese. And what the equation tells us is that she can still go to Zanzibar up to 8 times when she goes to the Chinese restaurant 4 times, right? So we are being efficient, or rather May is being efficient, meaning in this case that she's exactly spending her $200 budget.